All right, numbers 1 and 2 are, well, they're double distributing, so it's not related to factoring directly, but there are some characteristics in the double distributing process that are going to kind of come out in the wash and that we can learn from in order to help us in the factoring process. All right, so we're going to multiply the x's. X by x is x squared. X by 5 is 5x. 3 by x is 3x. And 3 by 5 is 15. Combine those like terms in the middle, and you get x squared plus 8x plus 15. All right, so what we get from this is really nothing new. It's that there is no coefficient in front of either of the x values, and with that in mind, it allows us to really just kind of cut out the fluff. If you wanted to, you could just take the 3 and the 5, add them together to get the 8, and then take that 3 and 5, multiply them together to get the 15. All right, but you'll see in the next example that that doesn't always play out. All right, because in this case we have 2x by x is 2x squared. 2x by 5 is 10x. 3x by 1 is 3x, or by 1x. Bless you. And 3 by 5 is 15. Bless you. Bless you. A lot of blessings today. All right, combine our like terms. We get a 13. All right, so 2x squared plus 13x plus 15. All right, so in this case, similar to the previous one, the 3 by 5 does give you the 15. But now it's not a matter of just taking the 3 and the 5 and adding them together to get the middle term. All right, it's, well, 3 plus 5 is not equal to 13, so there you go. All right, what you actually have to do is multiply the outer terms together and the inner terms together and then add them up. Right, so in the case of a leading coefficient other than 1 for x, it makes more sense to do it out rather than looking for a shortcut. All right, but either way, what we want to be able to do is gain from this to help us in the factoring process. All right, so let me take you through number 3 because we have to go the other way. Now, there are a variety of different approaches for factoring trinomials. This is the one over the years that I've settled on as, I'm not going to call it the best one, but really the most procedural one, the one that involves the least amount of thinking and the most doing. All right, so because there is, I mean, the suggested method for factoring a trinomial is actually guess and check. That's actually the considered to be the best way because that involves you using your number sense. All right. But what I've discovered over the years is that humans don't come standard equipped with number sense. It's something you could work towards gaining, but it's not always something that people get at the same time and get in the same way. All right, so we're going to go with the procedural approach. All right, this works for any polynomial in the form of ax squared plus bx plus c. All right. So what we're going to do is we're going to create an x chart. All right, so that's similar to the last strategy that we learned. Create an x chart. But instead of putting the 4 on top, we're going to put something else on top. Right? Well, it'll involve the 3. What we're going to do is we're going to put the product of the a and the c value on top with the b value on the bottom. What?
So 12.
12.
Yeah, it's steps. Yeah. Yeah, there's nothing to get yet.
It was like,
This is an instruction.
okay.
Yeah. It's like if I were to say, wake up in the morning and brush your teeth, and you say, I don't get it. But there's nothing to get. I'm just telling you to do something. All right, so you take the A and the C values and multiply them. So the A value is the 3, the C value is the 4, so we're going to get a 12 on top. The B value is 8. So far, that's the first significant difference from the way we were doing it and the way we're going to do it now.
Wait, why, I just don't get why you do it differently, or like, I thought they were the same thing.
This one has a leading coefficient that's not equal to 1. All the other problems that you did either had a GCF or a leading coefficient equal to 1.
So is this like why you're doing it this way instead of the other way?
Exactly.
Would it work at all if you did it the other way?
You will fail miserably.
Got it.
Yeah.
Wait, so how do you know to like do it to get the columns of A and C?
So anytime you have a leading coefficient that's not 1, you're going to use that approach. A
For like the
times
3x squared?
Exactly. Now, just so you know, this strategy works for the cases where the leading coefficient is equal to 1 also. So even though the other method is simpler, it doesn't always work. This method, more complicated, but it will always work. All right? Michael.
So do we use this when we can't find a GCF?
You use it when you can't find a GCF, exactly. All right, so we're gonna go to our calculator and figure out the side values in our X chart. Or, I mean, you could just try to use your number sense. All right, I gotta set up my calculator again. I wrote it up on the sideboard here, if you need it. I did it a little bit differently in the other class. If you wanna change it, you can. But in this step, in the Y2, that's where you would just put whatever that top number is in your X chart. Right, so you don't have to do the alpha math to get the A. You could just say some number. But if you want to, I can show you how to do that later. All right, so in this case, it's 12 over X. And then the last one is Y1 plus Y2. So you want to be setting your calculator up so that this is in there all the time, because there's no reason why you would have to delete it, right? So, but you also want to familiarize yourself with how to type it in. The day of the Regents exam is going to be a different story. Tests and Regents exams work obviously differently. On a test, they'll never ask you to clear your calculator or reset it or anything like that. On the Regents exam, the very first thing they ask you to do is to reset and clear your calculator, right? So anything that you store in there is automatically going to get wiped out, right? So if you don't know how to type some of this stuff in on your own, then what's the point? You know, like you're not going to have access to it, so it won't be of any benefit, right? So take some time and I would say learn why we're typing this stuff in so that it's easier to remember how to type it in. All right, that being said, we go to our table. Oh, I changed my settings for a different class. Let me just fix it. I'm looking in Y3 for the 8. All right, so, oh, and also, this reminds me, if you're borrowing one of my calculators, you never know who used it before you. It could have been a calculus student. The first thing that they're going to do when they get a calculator from me is they're going to clear out all the stuff in Y1, 2, and 3 to put in the stuff that they need for their class. So when you borrow one of mine, this stuff may not be in there. So you may have to, by necessity, know how to do this. All right, so in this case, we lucked out. The Y3 of 8, it happens very early on. It corresponds with Y1 and Y2 of 2 and 6. All right. So now the big question is, okay, cool, what do we do with this information? What we're going to do is we're going to replace the 8x with this new information. All right, so these two values, the 2 and the 6, are going to help us to replace the 8x. So I'm going to write 3x squared plus, instead of 8x, 2x plus 6x plus 4. Then we're going to factor by grouping. Anytime you have 4 terms in a polynomial, you factor by grouping. All right? Or anytime we have 4 terms in a polynomial. There are other situations, but we're not going to get into those this year. All right, so what's my GCF on the left? X, yep. So I pull out an x, I have a 3x plus 2. What do I pull out on the right? A 2, positive 2, so we keep the sign along with it. The- exactly, that binomial should be the same. Now remember, a nifty shortcut to this is once you know what the binomial is on the left, you know what the binomial is supposed to be on the right. You just figure out what the multiplier has to be in order for that to equate to what you started with. All right. Now I could just yank out the 3x plus 2. If I withdraw that from the polynomial, I'll be left with just an x plus 2. And that would be our set of factors. All right, so let's tackle one on the next page. Let me get something juicy here. Number 7. That's a good looking problem right there. It's got some oomph to it. Definitely the leading coefficient is not equal to 1. All right, so we're going to use this method that, again, it's really just the same method as the last one. The last type of trinomial factoring. We're going to multiply the a and c values together. So I'm just going to label it out on the top. I'm going to write a above the a value, b above the b value, and c above the c value. Keep it simple. So a gets multiplied by c, so it's going to give me a 4. And a 5 on the bottom. All right, so again, that 4 is a times c. All right, so I'm going to replace the 12 with a 4. Go to my table. In Y3, I'm looking for a 5. Works out nicely. It's the first entry, first meaningful entry. 1 and 4. And you know, like a product of 4, you're not going to, even if you did it by hand or in your head, you're not going to be looking too long before you find it. You know, 2 times 2, 1 times 4, maybe get some negatives involved. All right. So I'm going to rewrite it, replacing the 5x with a 1x plus 4x. So negative 2x squared plus 1x. You could just write x if you want, but I'll write the 1x plus 4x minus 2. Split it down the middle and pull out your GCF. All right. Now, I'm going to tackle this one slightly differently from the previous one. I'm going to factor out on the right-hand side first. The reason I'm choosing to do that is it just looks a little cleaner. All right. I think it's pretty obvious what the GCF is on the right-hand side, right? What's that GCF? 2. So positive 2, 2x minus 1. All right. So now I know that I have to have a 2x minus 1 on the left-hand side. What's the multiplier for that in order to make a 2x minus 1 into a negative 2x squared plus 1x? Negative x. All right. And I can withdraw the 2x minus 1, leaving me with a negative x plus 2. How do you do which part? You're talking about from this step to this step?
Yeah.
Okay, all I'm doing is I'm withdrawing a 2x minus 1 from each part. And when I do that, I'm going to have a negative x and a positive 2 left over. That's going to combine together to give me this. And since I'm removing just one 2x minus 1 from each part, that becomes my coefficient. So it doesn't matter how many times the 2x minus 1 is there, you're only removing it one time from each piece. So we only write it for one time. All right. Now, I wrote it another way because we can swap components of a polynomial as long as the signs go along for the ride. So instead of writing negative x plus 2, I wrote 2 minus x. That's perfectly fine. The reason I'm mentioning that is because multiple choice questions exist. They are a thing. And so it could be the second product that's the choice, not the first one.
So you don't like outside of the parentheses for the first row after you start factory, where'd you get the 2 from? Like, on the outside? Because I'm confused.
Where did I get this one?
Yeah.
Oh, the GCF for this.
Oh, okay.
All right, so let's do one more.
What about number 6?
Number 6. Yeah, number 6 looks good. All right, so again, A times C goes on the top. So A, B, C. So 2 times negative 36 would be what?
72.
Yeah, negative 72. And on the bottom, I put the negative 21. All right, so my y equals, instead of the 4, I'm putting negative 72 divided by x. Go into my table, and I'm just on the lookout for a negative 21, and I get that with a 3 and negative 24. So 2x squared plus 3x minus 24x minus 36. Split it down the middle. On the left side, I have a GCF.
1.
For the numbers, yeah, but what about the variables? Can I pull out a letter? X. So when I pull out an x, I'll have what?
2x plus
2x plus 3. All right, so I now know that the binomial on the right-hand side needs to be 2x plus 3. What should my multiplier be then? Basically, what do I have to multiply that 2x by in order to get a negative 24x?
Negative 12.
Negative 12. So now I have that common 2x plus 3. When I withdraw the 2x plus 3 from each part, it'll collapse down to just an x minus 12. Alright. Because really, I mean, the reality is any one of those situations, it is a unit on factoring. So any one of those word problems is going to involve factoring in some way. Most of the time it's area that you're working with. So as long as you know the appropriate area formula, you can usually piece together what the correct approach ought to be. So let's go with, yeah, we'll just do number 14. So a rectangular painting has an area of, well, that. Area is equal to length times width for a rectangle. They tell us the length is equal to 2x plus 2, and we need to find the width. So 2x squared plus 8x plus 6 is going to be equal to the length, which is 2x plus 2, times the width, which is unknown, all right? So since we know that we're dealing with a trinomial, in order to find the width, I just need to determine what the binomial would have to be that when multiplied by the 2x plus 2 is going to give us that lovely looking trinomial. All right, so I just start off with the leading term. I want to get from a 2x to a 2x squared, so what do I have to multiply by? X. The n term is, I want to have a 6. I'm starting off with a 2. What do I have to multiply by? A positive 3. All right, so your width is going to be x plus 3. We always state the units. Area was square centimeters, so linear units would be just centimeters. All right.